Yeah, we're live.
Oh, wow. Here we go.
Well, I'm glad we didn't utter those next sentences. That could have been awkward. Hi.
Hello. Welcome.
Haven't seen you in, 3 years.
It's good to be back.
Yeah, got the goosebumps. Also, it's cold in here, so that might be the goosebumps as well. It is like fall outside, right? I mean, is anybody else cold?
Yes.
It's just me? Okay, it's just me. Yeah. Anyway, we're
Hi.
here, man.
Should
Hi,
we introduce
guys.
ourselves?
Yeah.
Okay.
Oh, wait. Oh, let me show the slides.
Oh, yeah, we got a slide.
I got a
We got a slide.
Oh, look at that.
Our slide.
There you go.
There we go.
Yeah, that's awesome. Wait. Can we get a...
Wait, that's not the title of our talk.
What is it?
I don't know.
Oh, it's something about... Spring.
Reactive, Kotlin, Spring.
Oh, does it like wrap off the side of the page?
Yeah, it's long.
It's fine. We'll just leave it like... Whatever, we're going to talk about software. And that's the title, a talk about software. Hey, before we get started, can we get a photo, a selfie?
Oh, can we?
Yeah.
You and I?
Yeah.
Do you want my phone?
Well, I've got a phone, but we could get them in the audience.
Oh,
too.
are you asking for all of their permission?
Yeah, do you all accept my GDPR cookies? Please. I don't know how to make that work in like binding. Maybe I just won't tweet it. Or maybe I'll just blur out all of your faces. That does work, right?
We could just use an AI and say, generate a DevOps room.
Right, yeah, full of people. And
Full
then,
of people,
Yeah, and I'm going to take this photo. I'm going to go home. I'm going to put it on the fridge and show it to my daughter. And I'm going to say, see, they listen to me. She won't believe me. Okay, let's get a photo, man. I'm so excited. I can't believe we're here for the first time in like years. It's been so long. Years. Okay, everybody say open source. Oh, it's so many. Thank you. Good stuff. All right, what are we doing here?
Oh, wait, we were going to say our names.
Oh, yeah.
I'm James Ward, Product Manager for Kotlin at Google.
Yeah. Woo. And I'm Josh Long. I work on the Spring team. That's it. We're good. Yeah. What are we talking about? We didn't actually talk about this part.
We're just going to write some code. Is that okay?
Yeah.
Is that okay if we just write some code? This could go horribly wrong, but we're going to just try to write some code.
It's fine. What's the worst that could happen? After 3 years of all that, this doesn't seem so scary anymore, Like, this is fine.
Writing code?
Yeah, it's fine. It's okay. No, we're going to talk about Kotlin because we both love Kotlin. You work on the Kotlin team over there at the big old Google ranch, and I'm a Kotlin Google developer expert. I don't work for Google, of course, but and Kotlin works great with everything. If there's one thing I would say about Kotlin, it's that it's pliable, right? They've done a really great job of making it work for all sorts of different use cases. It is trying to be the best way to build things in the respective verticals. So the Kotlin team has been very good about really going after like server-side, making it a better Java, making it a better Android, making it a better whatever, and it goes beyond.
Better all the things.
Yeah. But it's not just like one language. It's many languages with lots of different, permutations. I don't know. It
Lots
goes
of different platforms. Yeah, we're going to go into that.
Yeah.
We'll go into that. We'll see some code.
So I think we should start on the server side, the back end.
Yeah, let's start. Start there.
Okay, so we're going to talk. So I'm going to preface all that with a quick sort of background here. Who saw the amazing talk by Stefan Nicole earlier on introducing the Spring Boot 3 AOT support? Okay, lucky people, you.
Okay, good.
And so anyway, there's this new Spring Framework release coming out in just a hot minute, like end of November, which is oh yeah. All right, good stuff. There's a new Spring Framework release coming out end of November, which is Spring Framework 6. It's the first in like years. September 2017, we released Spring Framework 5. This is a new major revision, and with it comes a lot of opportunities, including a new baseline JRE requirement for JRE 17, Java 17. Jakarta APIs have been updated. AOT, there's a new AOT engine. So all that is like really interesting, and I encourage you to check it out. We're going to be using that, but it's not yet done. So
things could go wrong.
They could go terribly awry, yeah, and it'll be fine. You'll enjoy it. We won't. All right. Let's build some software.
Let's build some software.
Okay.
I think we should use Kotlin though.
Okay, that's fair.
Is that okay?
Yeah, that
Can we
makes
use
sense.
Kotlin?
So this is very important. This bit right here.
Yep.
Nothing else works without that. Okay. We're going to go to start.spring today. It's just worth restating.
Wait, what site is that? What site?
Start.spring.io. And it's worth restating. This is my personal favorite place on the internet. My second favorite place on the internet. Darn it all. Already it's the first error. It's all downhill from here. It's my second favorite place on the internet. My first favorite place, obviously, is production. I love production. You should love production. You should go as early and often as possible. Bring your kids, bring the family. The weather's amazing. It's the happiest place on earth. But if you haven't been there, then you can begin your journey here at start.spring.io. So, we're going to build a new piece of software today. We're going to call this what? AOT, maybe?
Sure, but select 3.0 M5 because we're living on the edge.
This is a creakingly old version of Spring Boot from like a week and a half ago. It has long since been superseded by better and more interesting software available in the snapshots, but even we're not that crazy, so we're going to stick with this. AOT's kind of, it's a terrible name, you know?
I don't know. Josh James.
Yeah, JJ, there you go.
JJ.
Yeah.
Wait, is that too short? We're going to run into errors.
Software demo.
Great.
A Bootiful demo. There you go. Okay. So, and we need some dependencies. So obviously, we're going to use Postgres, right?
We're using Postgres.
Postgres is a nice SQL database out there. We're going to use the reactive web support. We're going to use R2DBC, the reactive database connectivity abstraction. And I think
Testcontainers.
Testcontainers.
Yeah.
It's in the abstract. It has to be here.
That's right. Well, and all these people chose not to be in Oleg's talk, so.
And by the way,
got to show you some test containers.
You're really missing out. I'll just tell you right now, you made the wrong choice. But I'm glad you're here anyway. Okay, so, good. Anything else?
That all looks right to me.
Looks good to me. Now
Java 17. We're using Java 17.
Using Java 17. By the way, let's talk about that. We're using Java 17. Spring Boot 3 assumes a Java 17 baseline. That is very important, crucially important, because a lot of people are still using Java 8. Just by show of hands, who's using Java 17? Oh, that's so good. So the rest of you, who's using a wrong version of Java? Something older than that. Who's using the wrong ones? Okay, that's a disappointing number in any context, especially given that Java is now 2 production releases behind. It's a year old. But consider what Spring is doing here, right? Spring, it took more than 5 years for Spring Framework 5 to Spring Framework 6. I can't see the future, nobody can, but you just extrapolate forward a little bit and say, okay, Spring Framework 7 comes out, 5 years from hence, right? So what year are we right now? 2022, so 2027, right? By then we'll have 10 more versions of Java. We'll be at Java 29, right? We have Java 19 right now. So Spring will still support writing code against Java 17 when people are writing code against Java 29. You're going to look so silly at the software party. So don't be that person. Do the right thing. Use the latest and greatest. But for now, it's not unreasonable to expect that you're using Java 17, and we should all be using Java 17. Java 17 is technically superior to Java 8 in every conceivable way. It's faster, more superior, more robust, more syntax-rich, more performant, more operations-friendly. It's also morally superior to Java 8. You won't like the look of sadness and despair in your children's eyes when they find out that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Java 17 is the right thing to do in 2022. Do the right thing, people.
You make it sound so easy.
It is
We're just
very
change
easy.
a number somewhere and magically it all happens.
It's exactly what happens. Yeah, exactly. So do that. You will be so happy when you do. Okay, moving on. So we have this thing. We haven't even generated it yet. Let's just hit generate and open this thing up in our IDE. I've got a little script here. Oh, the Wi-Fi is amazing. I got a little script here that's just going to open this up for me. It literally shortcuts the process of unzipping and running idea space pom.xml. This is normally the point where I say we don't care what IDE you use, but yeah, we're doing Kotlin. You don't have any other choice.
You can use VS Code. You can.
I mean,
but
I can use command alt butterfly too, right? Like,
yeah. You're gonna have a better time if you use IntelliJ.
Yeah, IntelliJ's got pretty great support there for that. Okay, so basically, I want to build an application that talks to a database. So first things first, we think about our schema. Is that true? Is that fair? So we're going to create a new file here called schema.sql. We're going to create the schema to manage types of customers, right?
Customers, yeah.
Okay, idea, serial, primary key, name, varchar 255, not null.
Old school types there. And let's do a create if not exists.
Oh, yeah, thank you. If not exists. Why did I do that? Okay, here we go. Good. And then we're going to connect to a Postgres instance, which is running in the background, hopefully. You haven't left us?
It should be.
Oh, thank goodness.
There we go.
Okay. So first things first, we want to initialize the database schema every time the application starts up. So SQL init equals always, because we're not using an embedded database, which by default, it would only run against the embedded ones. And then we need the data source. So the Postgres, the password is Postgres. The username is Postgres. And the URL is R2DBC PostgreSQL.
PostgreSQL.
Localhost Postgres, right? Okay.
That's it. I think you got it. but
Sweet nectar.
Configuration is always the hard part.
It is the hardest part. Let's get that out of the way. And now we can write code to work against that data type. So we're going to create a data class here. By the way, is that font? Oh, yeah, of course it is. It's bigger than a building. Here, you can see it, but just in case. Here we are. So it's going to be a data class, val ID int. And so what we're doing here is we're creating a primary key. I'm going to signal as much by using the Spring Framework at ID annotation. This is what's called foreshadowing, friends. At ID. Keep that in the old noggin.
Yeah.
Okay.
Let's make that nullable, because
fair,
before you talk to the database, you don't have an ID. So
there.
if you send null, then
Boom. Fixed it.
Boom.
We need a repository. Now, in the Spring data ecosystem, there's this amazing mechanism where you can create a repository by creating an interface. And if you want to benefit from some of the pre-packaged Finder methods and all that, you can inherit from one of our interfaces. You don't have to implement the interface. You just extend from it, and Spring Data will do the rest. That said, we're using Kotlin. So we could just use the reactive CRUD repository. But we have a unique opportunity here, right? Spring and Kotlin play very well together. So we're going to create a customer repository. Extending coroutine CRUD repository, okay? I didn't even know that existed until, I think, last year, when you and I accidentally stumbled upon it.
We stumbled upon it. So should we give some details on what that...
Please do.
Okay. So if you're using Spring Data and you want to use this cool, easy style to talk to a database, you have a lot of different options for how to do that. You could use the blocking options, which are based on JDBC. It's been so long since I've used JDBC. I've almost forgotten the name, thankfully. So
it's a nice piece of tech.
But if you want to be reactive, then you can use the R2DBC based stuff. And then there's different APIs that you can choose from in the reactive world. So if you're in Java, you're probably going to use, what's it called, the Reactor CRUD repository?
Reactive,
It's just called Reactive CRUD repository. Yep. And that exposes Reactor APIs. And that's great. You're non-blocking, awesome. But if you're in the world of Kotlin, you can be a step a little better and not have to do the Reactor APIs. The Reactor APIs, they're great, but in Kotlin, we have something better that we're going to show you. So we're going to use coroutines on top of that R2DBC CRUD repository, and we'll see how that gets exposed in a minute.
What's a coroutine?
Oh, we'll talk about it.
Okay.
Let's write some code.
Okay,
Yeah.
some code. So we've got our repository, we've got the schema, we've got our entity. Do we have an HTTP endpoint? Let's build an HTTP endpoint.
Let's do that.
Right, okay, so I'm just going to use this. This is a nice chance to talk about some of the deep-rooted sort of integrations between Spring and Kotlin. Remember, we introduced native Kotlin support in Spring Framework 5, again, more than 5 years ago. It's been in Spring Framework proper, in the code base, alongside all the other code that's been there for decades now, since Spring Framework 5. We've had Kotlin code next to Java classes in that code base for years. It's not a separate jar, not a separate project. It's in the jars that you use when you use Java and Spring together, right? It's alongside that, and it's just you're missing out on all these cool classes that do more interesting things when you're running inside of Kotlin. And a unique opportunity presents itself when you're using Kotlin because you have this amazing ability to create DSLs, and part of that is something called an extension function. So these are like secret levels that exist only for Kotlin programmers that you can unlock by using the language, but they're not accessible to you or visible to you from Java. So you've got this whole world of nice, sleek integrations through the Spring ecosystem that are there. They're dormant in the jars, just sitting there doing nothing until you write Kotlin code. And so, and this is, by the way, in the Spring team, we're all fairly autonomous and loose. Each project has their own sort of cadence and all that. There's no from on high mandate that all projects must support X, Y, or Z, right? Obviously, we try to have central themes that are common to all the projects, but there's no requirement per se that we do. the Spring projects, each of them in their own way, in their own time, all just eagerly adopted and embraced and provided Kotlin DSL. So you'd be surprised by how many projects just have these great DSLs, like Spring Data, Spring Security, the web support, Spring Cloud Gateway. I mean, just all sorts of projects in the Spring ecosystem have, DSL. So here's one that I quite like for HTTP, right? You could do this. You could say, let's create an HTTP router, a functional router, but we're using Kotlin. We're using coroutines, right? So instead, and by the way, this is a DSL that you can't do in Java. There's a something like it in Java, but it's nowhere near so succinct. But even still,
it's probably worth pointing out real quick that you don't have to use it this way. You can use the traditional get and
add controller and get mapping. Yeah, of
and
course.
do all that. Like that's totally possible, and that does support coroutines, which we're going to talk about in a minute as well. But we're doing like the new fancier Kotlin way.
Yeah, we're trying to embrace all the idiomatic Kotlin goodness in the Spring ecosystem. And by the way, there's just a lot there. It's not just a fresh coat of paint. It's just fundamentally really nice. Look at this data class, right? I mean, it's old hat for any Kotlin developer, but look, Ma, no Lombok, right? This is wonderful. So let's say we're going to build an HTTP handler that returns customer data, right? So I'm going to inject a pointer to the customer repository, and I'll send back a response. I'll say, okay, but the data, we're going to resolve it through a coroutine, which is a suspending kind of thing. So we use this extension function called body and await. This API doesn't exist if you're using the same exact server response.ok fluid DSL from Java, but in Kotlin it presents itself because it makes sense that it would. So customer repository.findAll, and that's about it, right? I think that's it.
Yeah, so there's some things that are not being exposed because we're using some type inference and stuff in here, so I want to point them out. So when we call that body and await, that's an extension function, so that's something that's being added on to whatever the type of OK gives us. And then that body and await is a suspend function because it's going into Kotlin coroutine land. So Kotlin coroutine land, that gives us a way to do non-blocking I/O, allows us to have an API for streams called Flow. And when we're in that coroutine land, we have to tell the Kotlin compiler that we're in Kotlin coroutine land, that we're calling a function that's using coroutines. And underneath the covers, the Kotlin compiler is doing a bunch of work to make a coroutine actually work. And so that all gets kind of hidden from us in a signature like this. But this does actually get unraveled into a non-blocking call.
Right, which is very convenient. Okay, so I think we need to actually have some data.
We do need some data.
So for the purposes of this demo, I'm going to create a little thing that you wouldn't have in your production code, but it's good for our purpose, for our demo here. I'm going to have a thing that when the application starts up, it's going to write some data to the database so that we then have something to work with, when we go to the HTTP endpoint. And for our sample set, I've decided that I will put a comprehensive enumeration of all the speakers on stage in this room that have names that start with J, and that's just 2 people, so that'll be enough. So runner, and we're going to create a Spring Bean here. Whoa, that's a thing I didn't know you could do in Mac. Come back. Here we go. All is forgiven. Good. So application runner. And we're going to use this repository again, inject that here. And then I'm just going to write some names to the database, right? So we're going to create some customers, and we're going to say that we want to create a reactive stream.
Oh, not a flux, but a flow.
No, of course not. We're going to create a flow of, right? Okay, James. Gosh, sweet nectar. And we're going to turn each one of these into a customer. So customer, null for the ID, but and this is the implicit parameter name for the single parameter that gets passed into that lambda. And then we want to save that into the repository. So we'll say customer repository dot save all, passing in customers.
So the whole reason we created the flow was really just that we wanted to take a collection of things and shove them into save all. We didn't have to use a flow there. That's kind of it's a little bit silly to do that, but
it's a little bit.
But hey, Okay, so now we're calling our save all, we're giving it our flow, which is our stream of customers that we want to save, and then we call the collect method on it just to print out the customers that we saved. And you'll see that IntelliJ is like, hey, you are not in the context of a coroutine. And to call coroutines, you need to be in a context of a coroutine. And so we need to resolve this. One way to resolve this is that you mark your function as being a suspend function, and then the compiler knows that, hey, this function calls other things. But for this use case, we actually don't care to propagate the coroutine out of this scope because we're initializing a database, whatever.
Yeah.
So what we're going to do is wrap this whole thing into something called run blocking, which gives us the coroutine context so we can use coroutines, but then it blocks on like the final resolution of all the coroutines that we would be using in that context.
Yeah, like that, right?
That's it, yeah.
Okay. Oh, did you see that? I did the code format and it fixed it.
Just as like, yay, amazing.
That's nice. Good stuff. This JetBrains stuff, it's going to go places. You just watch. It's going to be big. Hey, who's using? It's been 3 years. I didn't even get to ask. Who's using IntelliJ of some sort, JetBrains technologies? Okay, good stuff.
Yeah, wow.
What about Visual Studio Code? Yeah, I'm with you. Visual Studio Code, it's becoming more present, more useful.
Couple people.
Yeah, there's definitely, I don't know, 20, 30 people, some more than zero.
More than zero.
Eclipse. Who's using Eclipse? That's the old guard. It's the Vanguard. It's the, wow, it's actually, I think the very large majority of people here are using JetBrains. When I first started coming here more than a decade ago, it was maybe 50-50 Eclipse and JetBrains. Yeah, the world has gotten very different. Okay, so we have this initialization. We've got our HTTP endpoint. We've got a repository. We've got our entity. I think we're good to go. You want to just
let's try it. I don't know. We probably forgot something, but
what could go wrong?
What could go wrong? Okay, so now we compile and run. Hey, that wasn't too bad.
So bad. Yeah, it's there. Goody.
Okay, we see our customers. Did you see it?
Yeah, I did.
You deleted them. It's just that the primary key generator is already incremented.
Just making sure that they landed where we think they did. Yep, there they are.
Woo!
Good.
We got customers in a database.
Now,
yay!
I think we're good. We're almost done. I'm almost ready to give it to you, but I do want to think about how we get this to production. Right? Is there anything else we need to add, or can we talk about packaging?
Yeah, so I think just to come back and highlight, coroutines support is just built into Spring, and you can use this syntax or you can use the traditional REST controller syntax, up to you. And we, in our controller, let's go see this thing. So find all returns a stream of customer. So there's two different ways that you can use, do async non-blocking stuff in Kotlin. You can have a suspend function, which is, you call it and it returns a result sometime in the future. Or you can do a flow, which is a stream that will produce values as they come in. And I'm sure that underneath the covers, R2DBC is, doing reactive streams or some cool thing. But the cool thing is that the flow from the database is connected to the flow from the HTTP request, and so we get non-blocking back pressure the whole way down.
Yeah,
and that's what's key with this.
That is super cool. And also we get through that API, we get a nice way to write code that composes well as you start to add more things into the mix. Okay, I think we're ready to.
I think we should try it.
Yeah, we should.
Oh, do you want to make a request? Do you want to see if it actually works?
You want to test it?
We should test it.
You silly. Okay, localhost. Customers. As I'm typing
yay.
this, yay. Of course, don't applause. It's okay. It was a demo. Of course, it was going to work.
Of course. Yeah. I mean, I wasn't real confident, but
why? Ye of little faith. No. As I'm typing this, I just realized it's been a whole pandemic, and I still haven't embraced HTTPI. I should.
You know what I do? I use the HTTP client thing in IntelliJ because it's great because you can actually put those files into source control. Anyways, it's pretty sweet.
Oh, fancy.
Yeah,
See,
you gotta switch to the new age of
it's not like
coolness.
I had much to do for the last 2 years. Okay, good. So we've got this. I want to talk about getting this into production. So one of the unique opportunities that presents itself with Spring Boot 3 is that we have a new Aot engine, an ahead-of-time engine that allows you to take your code and then post-process it at compile time. And at that point, you can then contribute metadata that then gets fed into, for example, the Gravian native image compiler. Gravian, for those of you who haven't heard about it, is a phenomenal piece of technology that hates your code with unmitigated passion, right? It just really, really hates anything dynamic and fun that you might do in the Java ecosystem. What it does is it looks at your code, it does a reachability analysis. It scans the code, finds all the types that you're using, and all the types that those types are using, and all the types that those types are using, and so on and so forth down the line, until such a point where it has found everything that your application, it thinks at least, is going to use. And this is a static analysis done at compile time. The problem, of course, is that for all of Java's stodginess and old syntax and the age of the JVM and all that, for all of that stodginess, it's actually got a lot more in common with the likes of like Lisp and Ruby and Python and Lua and P. I can't say it. It's not a language. I refuse. But it's got a lot more in common with these other languages than it does the likes of C or C++. It's not one of those languages, right? It's actually a very dynamic language. You can, in a Java lang string, in the source code, have the code for a class file, compile that string into a .class file on disk, load that class into the class loader, reflectively instantiate an instance of it, create a proxy out of it using JDK invocation handlers, serialize it, all in terms of Java lang object and reflection, right? You never have to have a concrete reference to that type in your code. You can do that all after the application is started, right?
That sounds amazing.
Yeah, but
it doesn't seem like something that you could do ahead of time.
No, because the compiler doesn't see any of this. So you need to make it aware of all the places where you're having fun. So things like loading things from a class path, resource, like a file or a property file or an icon or whatever, serialization, reflection, proxies, J&I, all the fun stuff that makes Java just so darn dynamic, you have to tell it about, right? And it'll bake like a shim, basically, into the native image so that it looks like it worked, but it just, it's all smoke and mirrors. You can't actually do true random reflection without a priori configuration. But if you're willing to furnish that configuration, then everything works great. And so Spring does 99% of the work there for you in Spring Boot 3. Wherever possible, we will furnish that configuration and feed it into the Gravian compiler. But even we can't see, even at the framework level, we can't see all the possible places where this stuff might be happening. So if you're using a third-party library and they're doing something, dynamic and fun, well, somebody needs to take account of that, okay? And so there's a couple ways that you can furnish that configuration. Either the projects themselves can have that configuration in those respective repositories in the code, in the meta-inf native image. They can have a bunch of JSON files that then will get picked up when they're on the class path and fed into the Gravian native image compiler. That's the ideal. That's what we all want. That's the dream I want to live. But, you can't just move the Titanic. It takes a long time. So in the meantime, there's a really interesting opportunity here. They're called the Gravian Reachability repository, which is just a bunch of config files that are shared by the community, right? And it's a stopgap. Don't get me wrong. It's a Band-Aid. This is not like Maven Central. This is more like, this is the one repository you want to see get smaller, right? Where over time, each of these config files gets moved back into the respective projects. But if those projects haven't yet added these config files to their own code, then this is a secondary place. And Spring Boot is the first framework to take advantage of this repository, right? This repository, we have contributed a lot of configuration to it, and other projects in the ecosystem that also use Gravian have also done that. So this is a community effort to sort of build out all this configuration, because Spring and these other projects, they don't want to be responsible for maintaining, whatever. Just pick any random third-party ecosystem infrastructure library. No individual project wants to take responsibility for maintaining those configuration files. So,
wait, why are we doing this again?
Well, because I wanted to use Gravian, but
why do we want to use Gravian?
Because it's really fast and it's really small. That's the important bit, right? And it makes your application, it dwarfs the footprint of your application, which if you're running in a context where you have metered consumption, such as a cloud. I heard you work for a cloud computing company. Oh, now I see why you're so antagonistic. You don't want me to take away the revenue. No. I get it now. No, so just like, look over there and the code gets deleted.
So faster startup time, lower memory usage.
Much lower memory usage, right? That's the important
I guess this
bit.
isn't the Gravian pitch talk, but.
But anyway, I want to do that. That said, there are some things, again, it's early days yet. We haven't released Spring Boot 3 yet. It's coming soon, but we're not there yet. There are some projects that don't quite have all the hints that they need to make this work. So we're going to make it work, and the ideal, the dream we all want is that you should be able to do Maven Spring. No, sorry, you should do Maven -p native -d skip tests and then do clean package, and that'll just work. But we need to have some hints for the reactive Postgres driver. Okay, so let's do that here very quickly. I'm going to create some hints, and we're going to use the Spring component model to make that work. So we're going to call this devox hints, and it's going to implement runtime hints registrar, and this is just a callback interface that you can implement where you can programmatically register hints that get fed into the Gravian compiler. And we only need to do this for 3 types as far as I can remember. So customer, right? This is a bug, and the Spring team will work on fixing this. And then 2 other types that should be in the actual...
class.java, I think.
Oh, .java, yes, thank you. Java, and then array, an array. So this is, we need to have something somewhere is reflectively instantiating an instance of an array of Java time instant, and ditto an array of zoned date time. So there's that. And then for each of those, I want to register them. So I'll say hints dot reflection dot register type it, and then member categories, and I want to let's just say all of them, values. But of course, I'm going to use the splat operator to expand that. There we go. Okay, good. So that's my hints. I need to tell Spring to use those hints to furnish them. So I'll do so this way. Class, voila. Okay, that should do the job. Let's go ahead and compile it and see what happens. So Maven -p native -d skip tests clean package. Is that looking good to you? Am I missing anything?
Fingers crossed.
Fingers and eyes and toes crossed. My goodness. This might take about a minute.
This is going to heat up the whole room, right? This is when you're
Oh.
Ooh, nice. Bring the marshmallow.
Yeah, exactly. It's like compiling Scala code. Hey-oh, hey. Oh,
Hey.
goodness. What happened? Nothing happened. It's just a dumb joke. No, but it's look, I can compile GraalVM or I can run Slack. I only have enough RAM for one, So, yeah.
It's doing amazing things right now.
Amazing.
Like I
Sorcery.
feel like it's like we're at stage 3 of 7 of magic.
Truly.
Like how do you take something built for the JVM and ahead of time compile it without the JVM, not needing the JVM anymore, and this thing becomes how big? The whole executable output of this is tiny.
Tiny, yeah.
Tiny.
Ridiculous.
Like no JVM.
Yeah.
And you can use UPX to even compress it further.
Oh yeah, that's
that's
crazy
cool
sorcery.
stuff.
Did you see that?
Yeah.
That's actually supported through build packs, by the way. Okay, that took a minute, which is not so bad.
Not so bad.
Okay.
But now the moment of truth. Is it gonna work?
Does it blend? Wait, what happened? Port, already in use.
Port.
Son of a gun.
See, I knew it wasn't gonna work, Josh. I knew that was not gonna work.
Okay, here we go. Take 3. There we go.
Oh.
Hey-o. So there we go.
right.
That's
You got
our
your native
application.
app.
Yeah, that's nice. That's hot sauce.
Wait, what was the startup time on that?
I don't even know.
Just do it again. It won't take long. There we go.
85 thousandths of a second, which is not terrible, but much more saliently, customers, right? There's the PID. Josh, I have this little handy-dandy script where I can measure the memory.
Oh.
So this basically does PS -o RSS and then passes in the PID. So I'm going to run that script thusly. Okay, and there you go. What? No, that's a lie. Where's my... Okay. What is this project? Oh,
is it supposed to be less than that?
It's the...
1.3 megs looks good to me.
It's like... It's the wrong binary name. That's why.
Got it.
There you go. 120 megs to run everything.
120 megs of memory. That's pretty awesome.
Yeah, that's a tenth of what... Okay, just being honest. Raise your hand if you're using... And it's okay, we all did it once in college. And raise your hand if you're using a gig of RAM in your application in production. Or more.
Or more?
Or more, yeah. There you go. Yeah. So again, if I said to you, hey, you can deploy 10 of these apps for the same footprint as you're doing right now for one, it's not bad. That could actually help, unless you're Google Cloud, Good stuff. So I think we got a service. Let's move on.
We got a service. Okay.
It's not a good one, but it's there,
Okay. All right. And now I'm going to take over operating Josh's computer, which means that the pace is going to come way down because, one, I don't use a Mac normally, so this is going to get interesting. Just open it. Yeah, there you go. Josh is just going to sit back, relax, have a beer. There you go. Your part's done.
It's been a long 20 minutes.
Okay, so where we're going next with this thing is to add test containers to it, because test containers are awesome. And we just want, really the goal with this is, see how many things we can do that might go wrong. And so here we go. Let's add test containers to it. Okay, so what I'm going to do first is copy our resources into our test directory. And we could have done test containers for the dev part of it that we were showing earlier, instead of spinning up a Postgres container that runs all the time, right?
That would have been nice.
That would have been nice. Why didn't we do it that way?
You should have gone to Oleg's talk. I'm telling you, it's
so good.
So good.
Okay, here's all we need to do to switch our tests, which we haven't written a test yet. We will. Don't worry.
No.
We need to put TC colon into our connection string, and then we need to tell it to use the TC image tag equals the version of Postgres that we want, which is 13.3. Did I get all that right? Fingers crossed. Okay, I think so. Well, we'll find out soon if I didn't. Okay, now let's write our integration test that's going to use test containers. So to do this, we need to auto wire into here our customer repository. And then that's all available there. Now let's come in and do our assertions dot assert equals. And when we spin up our app, we create 2 entries in the database. Right. So I'm going to say that we're going to have 2, and then I'm going to go to our customer repository, and I'm going to say find all, and then I'm going to get a count on those. Okay, and it should be 2, because remember we're initializing the database up at the beginning of our Spring Bean. Okay, but you'll see that count.
Well, we don't delete them though.
Oh no, this is in the test container though.
Right. Thank you.
Okay, so when we call count, it's like, hey, you're going off into coroutine land, because to do a count on the flow that comes from find all, now we're in coroutines. And so again, we need to wrap this into our run blocking, which is it's great. We don't need our test to be non-blocking really. So, okay, that's my terrible, terrible integration test. But should we try it?
Yeah,
is it going to work?
Yeah.
Oh, you want to close this thing?
Don't you? Yeah. By the way, so that makes 3 places you should want to go, right? Production, start.spring.io, and coroutine land.
All right. Fingers crossed. Is this going to work? Run our test? Did I forget anything? I don't know. Okay, starting up Spring. And what we did see, yay!
Huzzah.
Hey, it worked. All right, so far so good on this. Okay, so what we did see was that when the integration test ran, it spun up the test container for Postgres. You can see that all happening in here using Docker. If you don't have a Docker daemon, then the Atomic Jar Test Containers Cloud, right? They can help you with that. Good. You don't even need a local Docker daemon, just do it in the cloud. Okay, but then you see, yep, sure enough, our process here added 2 customers to the database, and then our test succeeded. Just to verify that it's actually working, let's change that expected to 1 and rerun that thing and see. We should get a test failure this time, right? Fingers crossed.
I'm rooting for a failure. Oh,
yay, test failure. That's what we were hoping for.
Yeah.
Great. Okay, we'll get that back to you. Okay, so we just added test containers. There's a number of different ways to use test containers. This is just by far the easiest. And if you want to have more control over the life cycle of the test container or across multiple tests or multiple suites, whatever, there's different ways to do it. But I love test containers. Think it's really making it so that I don't get those errors where it's I know you like to use H2. For me, I ran into a lot of issues because I was using H2 in local development, and then when I went to CI, then things broke because my database was different. And what I like to do is just use the same database everywhere.
All the way through. That makes more
all
sense.
The way through. Yeah. Okay, so that's great. We got test containers wired in and working, so that's all awesome. I want to switch gears, and it's going to be a big gear shift. So hang on.
Okay.
What we're going to do is, we don't have a UI. We just have like this REST service, and I want to see like, can we throw like a Kotlin UI on top of this thing, and do that in?
Yeah.
We've got 11 minutes left. We'll see. But here's the hardest part. We have to switch our build tool, like midstream. So
this is where things get dicey.
This is where things get real dicey. It's hard enough to like switch a build tool normally. We're gonna do it live.
We debated whether we should write a kernel extension on stage or switch build tools, and which one would be like more risky.
More risky?
So we chose this one.
Okay.
Yeah.
I just ran the fancy dancy script to convert this over to Gradle, and it's saying load Gradle project. So keep your fingers crossed. We hopefully just did a migration from Maven to Gradle, and hopefully it's going to work.
And by the way, when you're not supposed to do that. You're not supposed to just yank out the build tool against which your IDE was running and evaluating your project. Behind the scenes in the log, if you actually inspect the logs for IntelliJ itself, it's printed out in ASCII art middle finger, just as we did that. It's a little known fact, but it's true.
Little known fact.
True. Yeah.
Okay, it looks like it imported okay. I do want to just walk through the structure of the build and the reason for why I use Gradle. Main reason why I use Gradle is because what I'm going to go into right now only has Gradle plugins, and so we had to use Gradle. What I'm using is all the normal, Spring Gradle plugins, but then also I'm using this Kotlin multi-platform, Kotlin JS and Kotlin JVM, because I want to write a quick little web application that's going to visualize our data from a REST service, and I want to write Kotlin that runs in the browser to do that, so I'm going to use Kotlin JS. And this is all like way experimental. Do not do this in production. But it's fun, and we're here to have fun, so, why not?
It's a terrible idea. No, I'm just kidding.
Okay.
Wait, no, just to be clear, it still beats writing React, okay? I will happily do this.
Yep, I'm with you on that.
Yeah.
Okay, I'm going to start up I want to make sure that my server starts still. So, so let's try that first. Boot run, and I don't know. Did we shut down the old one? Am I going to get a port conflict?
I don't think we did, which is a little awkward for us.
We'll find out here in a second. Oh, you're right. We didn't. How do we do that?
I don't even know.
Where is it running?
It's over here, I hope. Oh yeah.
Oh yeah, right there.
Please be the one.
Pair programming. That was it. You got it.
You got this.
Okay. Let's try that again. Make sure that our server still runs after the Gradleification of our build. Okay, yay, our server is working. Okay, now let's go start up our web application. So Gradle, and then web, and then run. And I want to do this in continuous mode. Continuous mode is one of the things that I really like about Gradle is that it's just like running, continually whenever files change and recompiling. So, okay, so we've got our web app compiling. It uses npm underneath the covers. Again, not recommended for production, but we hopefully will have a Kotlin application compiled and be able to run it in the web here in just a second. While we're doing that, let's go take a look at like the build definition for my Kotlin JS project there it is, has some configuration for how to like target the browser and then some dependencies and stuff. But yay, okay, I think it kind of worked. Let's see, like we get a blank screen, that's good. Let's go inspect, and if we go to our console, we should see hello world. Yay, it worked.
So you've got Kotlin types that were compiled to JavaScript.
Let's go see the code for this thing. So there's my function main and println hello world. Great. Let's make a change and make sure that changes actually work. So this is going to recompile. Again, this is all like not optimized. It takes a minute, but there we go. We see a hello DevOps. Cool. So that's working. But what we really want to do is take our data from our database through Spring and render it into a web application. So that's where we want to go. To do that, the main reason why I want to show you all this is because with Kotlin, we can share code to multiple platforms. And I want to be able to share some of my code that we wrote in the server part. I want to be able to share that, in this case, just to the web and the server. So not super interesting in this, well, maybe a little bit interesting.
So what other target platforms are there?
iOS, Mac native, Linux native, Windows native, and WASM is being worked on, and
So the native, that's Kotlin native.
Android,
that's not the
of
same
course.
as native Kotlin.
Android is
Oh,
a platform.
Yeah.
Yeah.
Cool.
So did I get them all?
I think so. That's
Yes. So
Mind-bending.
there's different ways to take Kotlin and target other platforms. Okay. So let's take this application, and what we need to do is do a little bit of refactoring here to take our code that is in our server. And I'm so bad at navigating your computer, just like total novice up here, but I don't know how to use a Mac. Okay. I really don't. Okay. So Linux user most of the time. Got to clarify. Okay, so I'm going to take my data class customer. That's my bit of shared code that I want to share. And I'm going to pop this over into a common module. The common module, what it allows me to do is share some code. So let's go create our customer here. And then let's just copy in. Oh, no. I made a mistake.
Go back to the main one, Command Z.
Yeah, there we go. Okay. Almost disaster. Let's try this again. Control V. That C and V are way too close together.
Yeah.
Okay, now before I forget, I'm going to say that this thing is serializable. Serializable is going to allow me to serialize customers out through when the web app consumes them is when I need to deserialize them. So that's why that needs to be at serializable. But then you'll see that in my data class customer, I have this at ID. At ID is something that is not multi-platform. It's something that we need on the JVM, but we don't care about on JavaScript. So what we have to do is we have to tell Kotlin that we're going to expect that there is an annotation class named ID. And now you'll see that, hey, now it's like, great, I got an add ID. But then it's like, hey, you know what? You are currently you have targets for JavaScript and for the JVM. You need to provide some implementations for those. And so let's go add our JavaScript implementation. So cool. And in this case, what I'm going to do is it's just an empty annotation, really. Nothing to do in that one. But then for the JVM, what I'm going to do is I'm going to say that my actual annotation class called ID is, I don't want to do it that way. I want to say, actually, my actual is a type alias. And so I'm going to type alias ID. So when we see ID, that's going to point to org, Spring Framework, data, annotation ID, right? So now I've swapped the implementation depending on the platform that we're targeting.
Is this basically like type def?
I don't know type def.
Macros in C.
I never did
like,
C or C++.
It feels like we just...
Okay, so now let's make sure we remove that from the server. We no longer need that from in the server because now we have it in shared code. Okay, now let's go try to actually use this thing.
It's not persuaded.
Oh, we need to import it. There we go, imported. We're all good. Okay, now let's go back to our web app and let's try to actually use this customer. So we move the customer into shared code. Let's say val customer, and let's create a customer and give it an ID and say James, and then let's println our customers. Okay, let's save that. Go back to our browser, and we will hopefully get to a UI in 3 minutes, but there we go. We do see our customer. Okay, now we need to actually call our REST client. So to do that, I'm going to create a REST client, so HTTP client, and we need to install into this thing content negotiation because we want to be able to handle JSON, and we'll import that JSON function there, make sure I get the right one. Okay, so that's our HTTP client. Now let's do our get our customers. So we're going to do that by calling our client. We're going to call the get method. We're going to call /customers. And then I'm going to, got to import that. Okay, and then we're going to get the body. And we didn't do a type on the left, so we didn't do the type on the right. We're going to say, turn this JSON that you get back into a list of customer. So now you'll see that there's some red there, and that's because I'm back in coroutine land. So because I'm in coroutine land, I need to be in a suspend function or run blocking. In this case, I do want to just do a suspend function main. And there we go. Now everything's all happy. Now let's go see if we can just print out these customers. Okay, and that should reload, and then we should see our customers from the database, which I think there will be more than 2. Yep, because anytime we run the Spring app against the already running Postgres, we get more. Okay, great. So now we're making a REST call to our Spring app, getting our customers, and then just printing them. But let's see if in 2 minutes we can build a UI for this thing. So I'm going to use something called Compose, and Compose allows us to create UIs for Android, and then JetBrains took it and made it so you can build desktop and web UIs as well. But let's call this customer UI. This is going to take customers, which is a list of customer. And then what we're going to do in here is let's build our UI. It's going to be very basic here. I got to import that, and then we'll star that. Okay, we've got a div. We've got a unordered list. And then we're going to say for all of our customers, let's map them. And let's do a list item. And then let's do text. And in our text, we're going to get the customer name. So that's our UI written in Compose for web. And then last thing to do is down in our main, let's say that we want to render a composable. We have to tell it the root node, the node element ID to use. And then what do we want to render? Well, we want to render our customer UI with our list of customers. And let's save that. And fingers crossed with 0 minutes left to go. If this doesn't work, we're just throwing in the towel and drinking a beer. Yay!
Woo! That was awesome.
All right.
Oh, wow.
Sweet.
Wow. Oh.
I can't believe it worked.
Okay, I barely. Proving once again that we will do absolutely anything to avoid writing JavaScript.
Yeah, that's right.
And on that bombshell.
Thank you so much for coming. Hopefully that was useful.
Wait, yeah, who learned something new? Who learned something new? Good stuff. If you liked this talk, please vote. If you didn't, it's okay if you don't. It's cool. It's cool. See you next year, hopefully. Thank you.
Thanks.
Cheers to you, brother. That was awesome.
Cheers.